All right, so hello everyone. My name is Ondřej Dušek, and I'm going to be presenting a paper on end-to-end retrieval generation in task-oriented dialogue. And this is joint work with Tomáš Nekvinda. Actually, it's mostly his work, but he was unable to be present online, so maybe he can respond to some questions if needed. Okay, so let me just give an outline of the talk. We'll start with essentially the reason why we wanted to do this, and then I'll introduce a few model architectures that we introduced. Then I'll describe our experiments, some evaluation results, and then I'll do a short conclusion. So why combine retrieval and generation models? So here we're focusing on task-oriented dialogues, and we're working with the MultiWOZ dataset, as did some of the papers in this session. And the problem here is that if we take the state-of-the-art generative models, they mostly produce very fluent dialogue. You know, that means that the responses actually fit the context pretty well. There can be some hallucination and you know, some ungrounded responses. That's always there. But the problem is that the outputs are mostly quite repetitive. Those models usually just go for the most frequent option, especially if you use greedy decoding and you know, don't go into sampling, which might exacerbate the hallucination problem. So that's the generative models. If you look at retrieval-based systems, here you have essentially human written responses because you're retrieving responses from your training corpus. But the dialogue, since the corpus doesn't cover all cases, might become disfluent. So the responses might not fit the context so well. So our idea was, let's combine those approaches. Let's go for a retrieval-augmented generation. Now, the main motivation here is to improve the diversity of the responses, to kind of make the dialogue a bit more natural, a bit more varied, and to preserve the appropriateness. So, you know, to avoid the problem of the retrieval-only models. Now, if you look at previous works in retrieval-augmented generation, it's mostly open domain systems or knowledge-grounded open domain systems. There is one task-oriented system by Shaliminov et al., but it doesn't track dialogue state. So there's not much done in this case, but all these models, the open domain ones as well, the overall workflow is that you retrieve some candidate responses that might fit the context somewhat well, and then you have a second step, which is the generative one, where you use the candidate response as a hint and refine it to produce a response that fits the context better. So that's also our setup that you were working with. So essentially, now I'm going to look at the models we're working with, and we're starting with like a generative baseline where you only have a generative model, and this is the standard two-stage end-to-end system, or like that most of the state-of-the-art systems are using. So the idea is that you encode the context, encode the past dialogue turns, the current dialogue state. You produce an update of the dialogue state, and now you can query the database, get the results, and based on the updated state and the result and the context, your response decoder can produce the results. So you have those inputs to the decoder, and you can produce the response. So that's the standard setup that we're working with, and that's like generative only. And now all the models that I'm going to be talking about will be just adding the retrieval into this setup. So the basic retrieval model, or the most used retrieval model, is a so-called dual encoder or Siamese network, and this is the one that we first started adding to the setup. So the idea here is that you have still exactly the same approach with the encoder and up until the point where you get to the database results, and here is where the retrieval comes into play. So the retrieval takes the updated states, the database results, and this is taken into the retrieval context encoder, and then you have another encoder for response candidates. So you have like dual encoders. You compute some similarity and find the best candidate responses. And these candidate responses are fed to the response decoder as a hint. So you have like one more input to the decoder. You have the, you have your context, you have the updated state and database results, and you also have the candidates as, or like the best candidate as a hint, essentially. So that's the basic setup for like the kind of most straightforward retrieval generation system. And if you look at how the dual encoder is trained, here you try to keep the context and the responses in a joint embedding space, and you train the relevant, the appropriate responses to have similar embeddings to the context according to some similarity function, which is usually just dot product. And here you maximize the similarity for the true response from your training data and minimize similarity for all the other responses in the same training mini batch, which means essentially like randomly sampled negative examples, assuming that your batches are randomly shuffled. The problem here is that the performance will depend on the way your negative examples are sampled. And especially in task-oriented systems, the responses are often quite similar to each other, and it happens very frequently that another response in your same training batch is actually a valid response to the current, to the current context. So that way you downvote valid responses. And also another problem is that the model gets bigger because you need 2 additional encoders for the retrieval setup. So our first idea was, let's improve on these problems, let's solve these problems, and this is where we decided to use the system action annotation that is available in the MultiWOZ set and many other Dialog data sets, and we went for a kind of action-aware setup for training the retrieval. And the setup is essentially the same. It's the only highlighted part is kind of different and new, and then the main difference here is that we don't have 2 encoders, we just have 1 encoder. So we only look at the context, and we use the action annotation in the data set to train the retrieval. Otherwise, it's exactly the same as the dual encoder set. If you look at a bit more detailed how we do the action-aware retrieval training, we use the so-called generalized end-to-end loss, which essentially arranges the mini batches for training with like a set of action. Let's say we have like 3 actions and 5 samples of each action in a mini batch, for example. And here your similarity is a dot product between essentially just context embeddings and so-called action centroids, which are just the mean of the action samples context embedding. So you only compare context embeddings. You're not looking at the responses. That's why you only need 1 encoder, and you maximize the similarity of your example and its own centroid. So essentially trying to bring the examples for the same system action or same semantic action closer together, and you try to spread different actions as far apart as possible in the embedding space. This needs the system action annotation, which is available in MultiWOZ, but obviously it's kind of expensive to get. On the other hand, you only need 1 encoder because you don't need to encode all the responses, and you don't have the issues with the negative samples because you know which kind of samples should be close together and which should be far apart. So that's the idea here, and that's kind of the action-aware model. And now the last step in our model building is kind of putting it all together, and that's where we created kind of like a retrieval generation hybrid model, which we dubbed AARGH because it's action-aware retrieval generation hybrid. And the idea is that we just take the generative model, and instead of adding separate encoder for the retrieval, we just fork essentially the last 2 layers of the encoder and use those for retrieval. So instead of just having encoder, like 2 separate encoders, you have a shared encoder, and then you have like the last 2 layers that are used for decoding the state updates, the database, and all this stuff. And then you have also like the copy of the last 2 layers, obviously fine-tuned, that also receives the state update and the database results, and this is used for the retrieval. So this is basically where the change happens. So there is no separate encoder here. It takes most information from the shared encoder, just the two layers are kind of distinct and trained or fine-tuned for the retrieval. And this is all in a single model. And so here you have the same setup as the previous ones. You again use the retrieved candidate as a hint to generate the response. Otherwise, yeah, it's same action-aware training. So you only need one encoder here for this part, and you don't need anything external because most of the encoder is shared. So you have a single model that basically first retrieves candidates and then uses them to generate the response. So let's now look at kind of like overview of all the models that we compare for the experiments. So we have our purely generative baseline, which is essentially the MinTL model, and which I showed. Then we have the dual encoder model. That's kind of the retrieval generation baseline. We also have a variant called polyencoder, which just modifies the way the retrieval is trained. Then we have our action-aware encoder with the generation model, so single encoder for retrieval plus the generative model. And we also tried the dual encoder in the action-aware variant as kind of a ablation. And then we have our the hybrid model, which uses everything in a single neural net. So we have those models, and we have several different ways of evaluating it. But let me first show our basic experimental setup. So we work with the MultiWOZ 2.2 dataset. We use the generative models. Basically, all use the T5 medium model from Hugging Face. If we have the separate retrieval encoders, they are based on BERT. And there's one quite important step in the training that we actually kind of had to use to make the models actually use those retrieval candidates for the generation, to kind of prime them to use them more. And that's called alpha blending. It essentially boils down to, instead of using the actual retrieved candidates, just replacing them by the actual true response some of the time. So we have two settings. In one setting, we just 5% of the time we replace the retrieval candidate with the true response. Another setting, we do it in 40%. So in this case, we really kind of want the model to copy a lot from the retrieval. So this is kind of an important step, because the models are actually quite sensitive to this setting, and we use greedy decoding to kind of make it fast and make it as accurate as possible. So we first evaluate only the retrieval step in an intrinsic way. So here we only talk about the retrieval encoders and not the generative decoder. We cannot actually use the standard metric, which is we call it K, because the action-aware models are essentially just comparing the context, so they would always get the perfect score here. So that's why we use intersection of a union on action annotation. So basically trying to see whether the models select responses that corresponds to the correct action. And we have like full match and no match rates on this. And then we also get blue score, essentially just comparing whether the responses are similar to what is expected. And as you can see, the action-aware models, be it the one with separate encoder and the AARGH model where everything is in one, score generally better. So they are able to choose better responses, or responses corresponding better to the correct actions. If we look at automatic metrics on MultiWOZ, so standard response generation evaluation on MultiWOZ, so there's the corpus informant success rates, again, blue score, but from the generation, not just from the retrieved response. We can also look at how diverse the response are. So we look at the number of unique trigrams and also the bigram conditional entropy. So essentially looking at how predictable the responses are. And we also look at how much the models are using the retrieved responses. So this is essentially like score against the retrieved candidates and the percentage of time where they actually copy the retrieval candidate. And here we can also see the comparison with some state-of-the-art models. So you can see that the scores are kind of comparable to state-of-the-art. And comparing our models with like the low alpha blending, this is just a selection there. The rest of the configurations are in the paper, by the way. If you look at the low alpha blending, we can see that we have better blue score, even though it's kind of slightly worse than the generative baseline, and we have much better lexical diversity here. If you look at the high alpha blending, we can see that the blue score really drops, but the diversity goes really high, and we have even better success rates and inform rates on MultiWOZ. We can also see that for the high alpha blending, it's essentially almost a retrieval model, because 85% of the cases it just copies the retrieval hint. So that's the automatic evaluation. And if we selected some models for human evaluation, which was relative ranking of models by it was an in-house evaluation by 5 people from our department. And here we could actually see that our AARGH model with a low alpha blending scored essentially best, or it has the best mean ranking. And the high alpha blending model actually scored significantly worse than, compared to all the other models. So it's significantly worse. So this kind of shows that the MultiWOZ evaluation metrics here, don't really paint a clear picture, or don't work that well. And the reason for this is actually that the high alpha blending models copy really a lot from the retrieved hints, and if the hints are not appropriate for the context, it really shows. So if I just look at this example, you can see that there is something about needing a taxi, and if you look at all the other models apart from the high alpha blending, they give a good response, which is fine. And here in this case, the response doesn't fit the context because it asks about the destination, even though the user gave the destination already. So that's kind of the main problem with the high alpha blending here. If you look at the low alpha blending models, we can see that it is actually able to produce kind of more varied vocabulary, which still fits the context in most cases. So that's the kind of higher diversity that we were going for. So we can see that the vocabulary is not so frequent here, so it's able to use something a bit more varied, and it also is able to produce longer responses. Where here this is about booking a hotel. And if you look at the generative baseline, it just gives the booking reference, same for this one just asked, but the low alpha blending AARGH model is able to actually give the full confirmation with all the details that are needed for the booking, or kind of to make the user aware of what booking they made. Obviously, it's still there's still some room for improvement. So in some cases, it produces a response. It's actually quite appropriate for the context, but a listing of all the possible train IDs that are in the database is not, and I'm sure it's not the appropriate number of trains actually according to the database results. So it's this is definitely some room for improvement here. So to just quickly conclude, we've built an end-to-end model that combines retrieval and generation in a single neural network. We only use a single encoder retrieval, which uses the action annotation. This outperforms our baselines, and it's competitive with state-of-the-art on the MultiWOZ data. It also provides high output by diversity, and this is not coming just from sampling. This is the diversity. It comes from using the retrieval hints. On the other hand, it's really sensitive to the hyperparameters and runs the risk on overusing the responses. So yeah, that's all I wanted to say. Thanks for listening, and I'm happy to take questions.
Very much for this help. And we have 2 minutes for questions. Yeah.
Hi, my name is AARGH from Harriet-Watt. So I was wondering what the intuition was behind thinking that the action annotation would help, because you're already encoding that in the context encoder. So you've got access to that same information on a token level.
Well, not really. Actually, in the context, you see the dialog context, you see the preceding dialog turns, you see the dialog act, but you don't see exactly what action the system actually took, or the gold standard action that was taken in the data. So, for example, I mean, if I say in this case, the action here that would be taken by the corpus, if you look at this response, would be a request departure location or something like that. So that's actually not included if you're not using the gold standard annotation. So you kind of the encoders have to kind of figure this out from the context.
Yes, I understand. And so one more question quickly. So at runtime, where are you getting the system action label from?
At runtime, the system action label is not actually needed, since essentially you're just comparing I mean, here in the during the runtime, you're actually just comparing your context to various contexts that you have in your training data. So essentially, you're trying to you're only using the action labels to train your context embeddings. So at runtimes, you only compare those context embeddings, and
Understood.
The embedding space is determined by that, but it's not needed during runtime.
Thank you. This is Angeliki Lazaredou from DeepMind. You first of all, do you condition? Do you retrieve multiple things from the?
I mean, it's theoretically possible, but in our experiments, we essentially just use the top results for the retrieval.
Okay, that's what.
I mean, anything that would fit the model size would work.
Yeah, that makes sense. It's just like a curiosity. So you mentioned the over reliance on the retrieved.
Yeah.
And so if we think about how the model works, you basically just attend to it without necessarily being somehow controlled from the question or the context. So I was wondering if you thought about maybe using the context as a way to gate the attention and to gate the attention on the retrieved evidence, such that to basically to have a way per instance modulate how much to allow the flow of information,
right?
Which is
right.
currently
kind of
which is currently basically done on the global level rather than on the per question level.
Right. Yeah. Actually, no, we hadn't thought of this idea, but yeah, it's a really good hint. Thanks. Because yeah, I think that this might help to kind of make the model actually use the retrieval a bit less even with the
or more even. I mean.
Yeah. True. Thanks.
I think there's one question up there, and I'll finish from the last one.
Hi, I have a question about how do you maintain the freshness of the database that you have? Like, let's say, with respect to your train example, the next day, how do you get the updated schedules, or how do you query for that?
Sorry.
So yeah, my question. So my question is, how do you maintain the freshness of the database so that your retrieval happens with respect to our most updated information? So let's say the train example that you showed, the next day when the new schedule comes in, so the user is asking for
So were you able to, because
Oh, you can't hear.
you know what, let me.
No, I can be more louder. I
Because
don't know. So I was asking, how do you maintain the freshness of the database that is used for the retrieval part?
I mean, there is no, you're asking about the database results, if they
Yeah.
are like relevant for the retrieval or?
Yeah. So let's say if the train example that you showed at the end.
Right,
Uh,
let me just see the, you mean this one, right?
Yeah. So let's say now the next day there is a new database, a new schedule that is running for trains or buses, whatever. So now how do you pass that information to the database so that that's updated information gets retrieved for generation?
Right. I mean, in this case, the the state is probably like not specific enough yet for the database result to be very specific. So you probably will not get anything from the database yet, and that's why you passed an empty result here. And then the only thing, the thing is that the model here is actually also taking the updated state here. So it kind of knows what, I mean, the retrieval does have access to the state update as well as the database. So it should be kind of all relevant to the current Dialog state.
So just like probably a follow-up question, can we
Can I
plug?
please
Okay.
answer in case of time? I think we're running out of time. So
Okay,
I
great.
have to thank the speaker again. Yeah, that may conclude the session, but before